In this SolidWorks simulation tutorial, we're going to run a static analysis on a chisel. We're going to run 3 different studies, each with its own unique load application. We'll then analyze the peak, max stress, and their location for each study and briefly go over the Design Insight tool in SolidWorks. You'll even get to see how you can plot mesh quality and aspect ratio. Alright, we are first going to set up our split lines in the part to more specifically locate the applied loads, and we are also going to go ahead and assign a material, so we'll do that now. We're just going to do plain carbon steel. We are going to use this plane 5 projected from the top plane, as you can see, to then start our sketch for our first split line. We will go ahead and select the midpoint of that line. And we'll go ahead and do our split line feature on this space. Next, we're going to do a sketch on this narrow face here. We'll go ahead and add a line. Right over the origin. And horizontally. Same thing, we'll go to curves, split line, and through this space here. We are officially done setting up our geometry and material. We can now move on to pre-processing, where we'll set up our 3 static studies. So now we're going to go to our simulation tab finally, do new study, static 1, static analysis. Go ahead and select that. We have our material selected. We're going to go ahead and apply our fixtures. We're going to do a fixed geometry on this end of the chisel. So we'll select that face and select OK. And for this applied load, we are going to right click external loads and do just a constant force normal to this end here, this edge, or face rather. We're going to select all 4 of these quadrants. Total, make sure total instead of per item is selected. And we're going to do 60,000 newtons. And we will select OK. The last thing we'll have to set up is our mesh generation. So we will right click, create mesh. We are going to click this mesh parameters drop down. We're going to keep it at standard mesh. For our width, we're going to do 10 millimeters. And for our ratio, 0.5 at the minimum. We will go ahead and select OK, let that run. Now I want to show you also our mesh quality plot. We will go ahead here. We can analyze, if we right click mesh quality, we can analyze the aspect ratio here, and we will select the green check mark, and you can see This gives you the quality of our aspect ratio. You want it as close to 1-to-1 elements as possible. Our max here, we can define that in our chart options. If we show max at 6, which is on somewhere on this edge, as indicated by the red. But if we right click mesh and go to details, we have 98% of the elements with aspect ratio less than 3, which is really good. So our mesh quality is high as it is with standard mesh. So now that we have our mesh generated, we can go ahead and run the study. We can see the result of the von Mises stress with the force being applied on that edge. Remember, we can show mesh if we want. Let's go ahead and do some post-processing here to label the min and max von Mises stresses. You can see, indicated by the red, max stress is way on the corner here, indicated in red, and our minimum stress is way on this side where we fixed the constraint. You can tell that if by looking at our yield strength of the material, our max stress is still less than the yield. So that means that this part will not fail with the 60,000 Newton load as it is currently set up. We can also, if we want, in our plot tools, if we probe along the edge, we're going to select on selected entities here, and we're going to click this edge here and click update. We can see a plot along that edge of the von Mises stresses along that edge. We can even view it in a plot so you can see how the stresses are higher once you get to the corners at the end of that line here that we selected. Keep that in mind as we go to our next analysis. It may be a little bit different. We can also view the reaction force if we right click on results, list result force, and select this face here. We can see pretty much all the reaction force is in the Z direction. If we set up our free body diagram, that would make sense, because since we're applying the opposite force in the Z direction, coming out to 60,000 newtons. Let's go ahead and briefly go over Design Insight. So you see this tool up here, Design Insight. If we click that, it'll basically show us the areas in blue, show the most vulnerable areas of where the part may see the most load and potentially fail. It's basically a graphic that can show you where to confidently remove material from the strongest areas that in this case are the translucent parts. So in this case, it's around the neck of the chisel and all on this end, covering the corners especially up on the sides, like a nice parabola. Let's go ahead and set up our second case study. It'll be another static analysis, so we can just right click and do copy study and static to, we'll call it, that's fine. All right, for case 2, we are going to again apply a force on this narrow face here, but this time we're gonna have the force distributed according to a parabolic equation. But before we insert the equation, we have to put another reference coordinate system. That's why we have these split lines here. So we're gonna go to reference geometry, coordinate system. I'm going to select this vertex in the center. We'll have our x-axis being the longer side of the rectangle and our y-axis being the short edge here. And we will select OK. Now we are ready to apply our force. We're going to keep everything the same from static study 1, except we are going to suppress this, do a same force type of 60,000 newtons once again, total. But now we are, now we are going to do non-uniform distribution checked. We're going to select our coordinate system that we had from before. And we are going to edit the equation. I have it copied, so I'm just going to paste it in. But we have to go back now and fix these x's. We have to do the x, y, z variables in quotations for it to work. Like so. And we'll select OK. Alright, with our load set up, let's go ahead and run. And you can see our peak stress now is in the center of that edge, 1.062 times 10 to the 8th. Still less than our yield strength, but not by much. Whereas before on our constant force we had the max at the corners, now it's in the center of the edge because we have the parabolic curve, and our minimum is pretty much in the same where it was before. Let's go ahead and see what our reaction force is. We right click, list result force, and select this face, update. We can see again the entire force is pretty much in the z direction, which makes sense. Let's go ahead and run our design insight and see how that compares. I'll throw a screenshot at the end of all 3 studies what the design insight looks like. So here you have most loaded more in the center of the edge as indicated in blue, and still same as before around the neck of the chisel, but definitely not as much concern in the corners now. So going back to the von Mises stress, if we use our plot tools again and probe along the edge, this time we will do unselected entities and select the edge. You'll see that it's the inverse. Instead of at the corners, the peak stress is in the middle on this line here. We are now going to copy static study 1 again for our third and final static analysis using both force and pressure. We'll just call it static 3 and hit OK. So now we are going to suppress this force, instead do pressure. We're going to do use reference geometry. We're going to select this face here along plane direction 2. We're going to do MPA, their units, 10. Make sure reverse direction is checked, and we will go ahead and select OK. And we'll add another pressure, very similar to before, normal to MPA 10, and select OK. Now we can go ahead and run this study. You can see now we're getting a max von Mises stress around the neck of the chisel because of the pressure along that face that we applied, and it is definitely higher than our yield strength, so this resulted in a failure, permanent deformation, and is different from the other two analyses because of this pressure load application. Let's go ahead and run the reactive forces. We'll select this face again, update, and this time you can see we have quite a bit of force reacting in the Y direction as well because of this pressure along this south face here. So we have reactive forces both in the Y and Z direction now. And we'll take a look at the Design Insight tool once again, see what areas of concern there are. This time it's away from the small edge of the chisel and much more where we applied the pressure on this underneath and around the neck. We have much more concerns of potential failures and not removing material around the neck, possibly even adding material there, definitely, because it is yielding, so we would want to add material around the neck. So what do you think of the Design Insight tool in SolidWorks? Do you think it's useful? Drop a comment below. If you found this video content useful, go ahead and subscribe to the channel, like this video. Consider supporting the channel by becoming a Patreon member where you get exclusive content, and link in the description, I'm going to include a free SolidWorks simulation guide.